Hey guys, so in this video we're going to be reviewing the study guide for exam 1 for Physics 111, which is Physics for Non-Calculus for Biola University. So I'm going to skip chapter 1, prefixes, scientific notation, and significant figures, because that I feel like you can just look at the book and you will understand it. And I don't want to make this video longer than it needs to be. So now let's move on to chapter 2. So for definition of average and instantaneous velocity and speed. So what we're going to do here is we are going to look at what an average is. So for example, if I spend $1.50 in the morning for breakfast or a candy, $2 in the afternoon, and $2.50 for the evening, then my average spent over the day is $2 per meal. Okay, so I spent $2 per meal. All right, so meal and meal, you get the idea, right? Now, what would be my instantaneous spending on each one of these times? Well, the first one would be $1.50 for breakfast, second one would be $2, and the third one would be $2.50. All right, so now let's translate that information into velocity. For example, let's say you're traveling at 15 meters per second, 20 meters per second, you end up at 20 meters per second. What's your average velocity? It will be 17.5 because we don't know anything else, right? Now, let's be really careful here because this will be speed because we don't know the direction. We're only assuming that it's positive. So in this case, we can also say it will be velocity. Now, let's move on to a different case scenario. For example, let's suppose you're going on a circle, all right? Or you're running a track. Let's say you're running on the track and you start from right in the middle. So let me just change colors. Let's say you start here and you go around the track, you run, and then you're able to do all this in 60 seconds. Okay. Now let's say the distance you covered, it's 600 meters, just to make it simple. So you covered 600 meters. Okay, so now your question may be, what's your average speed? Okay, well, because remember from our previous videos, and if you don't remember this, then I would suggest you to look up the description of the video, because I'm going to suggest you and refer you to previous videos where I go more into detail into each concept. So speed is just distance over time. Okay, then what's our distance here? It's 600 meters, right? What was our time? 60 seconds. So 0 cancels out, and then 60 divided by 6 gives you, let me put it into my calculator, gives you 10, right? 10 meters per second. All right, so that would be your average speed. Now, if they ask you for average velocity, what do you guys think it would be? 10 meters per second, maybe? Not really, because remember in velocity, again from our previous videos, we know that this is displacement over t. So what was our total displacement? We started here and we ended back here again when we ran. What does that mean? Theoretically, we displaced 0, right? Because we didn't move from our beginning initial point. We didn't end up anywhere else. So our displacement is 0 meters, and the time can be whatever it wants. But our average velocity then will be 0 meters per second. So that might be one of the tricky questions where your exam is a little bit trying to define if you see what's going on there, and those points can be vital. All right, so there's that. Let's see, we covered the first part. So we have this part down. All right, relationship between velocity and acceleration. So let me just move on to this. switch colors. Back to green. There we go, green. All right, so relationship between velocity, acceleration, time, and distance formulas are on your sheet. So for this one, I'll be attaching the document in the description of the video, but these are just these formulas, and what that means is just the kinematic videos. Kinematic formulas. So just to recap really quickly, x equals x naught plus v naught t plus 1 over 2at squared. V equals to v naught t, v naught plus 1 over 2, my bad, plus at. Okay, and then what I think is the third most important one is x squared equals to, I apologize, that's v squared equals to v naught squared plus 2a change on x. Doing a lot of problems over the years, this is what I think is the most important formulas. So know those by heart because they will for sure come in handy in your exam. All right, so we got this out of the way. Interpret v versus t, x versus t, and a versus t graphs. So lab graphs, this comes with the lab, so for constant velocity, acceleration, free fall, and constant x situations. So let's just cover that really quickly. All right, actually I might need this formulas. So for those formulas, usually what ends up happening is you have an x and y, and over your y, it's going to be your displacement, for example. So this will be, and this will be time. So time and position. So this will be what we call x versus t. So now, if you see a graph that's, for example, a line, that was a terrible line, I apologize for that. So if you see a line on an x versus t graph, the professor may ask you, what's the acceleration of this graph? And then you would have to know. So I'm just looking at it, and this answer would be 0, and I'll explain to you why in a little bit. So right here, so now we're going to look at our formulas again. Right here, let's look at the first one. So let's write that out again. X equals to x naught plus v naught t plus 1 over 2at squared. So notice how there is an x and there is a t, right? So x equals x naught. Well, this seems to be x naught, right? Because that's where it started. What's for v naught? And it depends on t. So if there was a v, right, a velocity over time, it would have to be increasing, right? Because let's say 5 times 1, 5 times 2, 5 times 3, right? And so on. I just chose 5 at random. It would be increasing. Is this increasing? It's not, right? What about with acceleration? If there was an acceleration, it would be like 1, 2, let's say 5 again. 5t, 1 squared, 1/2, 5, 2 squared. But it's not increasing, right? Because it's addition, it's not. Therefore, not only our acceleration is 0, we can also conclude that our velocity is 0. And if you think about it, if you're standing in a point still on time, this right here, your position won't change. If you're waiting for a bus, right? You're just sitting down, time goes by and you're still waiting for the bus and you don't move, right? That's what this graph means. All right, now let's move on to another one. Now, I'm going to use blue. Now, for example, what does this mean? If this is v, if this is velocity and this is time, all right? So now for this one, what does it mean if it's flat? What does it mean if it's flat? It means that the velocity is constant, right? because the velocity is not changing. Same thing here, our position wasn't changing. In this case, our velocity is not changing. Therefore, that tells us that there is no acceleration, because from looking at our second equation right over here, this one, v equals v naught plus at. If we stay at v naught, that means that there is no t, right? So our velocity is constant and our acceleration is 0. So now what happens if all of a sudden I decide to, oh, and by the way, this, if the velocity is constant from here, right, this would mean it's increasing. So what the graph will look like, it would be like this. So you have an increase in position because you're just moving linearly according to the velocity times time. All right, and now lastly, if you have a graph looking like this, for example, that is a quadratic, that means that the acceleration, there is an acceleration. Because again, x equals to x naught plus v naught t plus 1/2 at squared, right? Now notice the t squared. Remember from our geometry classes and trigonometry where if it's a square, it means it's going to ramp up, right? If it's just linear, so linear being y equals mx plus c, it will go in a line, which is what we have right here. And if it's constant, it's just going to be y equals constant, right? And it would just be a flat line. Well, so that's what we have here. So I hope you see the connection. If not, take a little bit of time to go over it. I know it's complicated, but it will come in really handy when it comes to solving those type of problems. All right, so now let's move on to the next question. All right, so we have this out of the way. All right, object falling in free fall or throw down up the air. All right, so for that one is from our kinematics. Again, I'm going to refer you to our video, but really quickly, it's just y equals to y naught plus v naught over the yt minus 1 over 2 gt squared. And I'll refer you to the link where I explain more about this, because I realized that I'm going a little bit too slow and I'm not going to be able to cover all of it without going half an hour or I don't know how long, but I'm trying to avoid that. So I'll put the video, I'll refer you to that one. So now add vectors, that's also a video that I have posted for you guys. So really quickly, it's just, for example, whenever you have a vector going at an angle, right? And then you have its x and y, or you know where the x and the y is, and you're given this angle right here. And then how do you break it into its components, meaning like the x and the y component? How do you break it into the x and how do you break it into the y? It's just, let's say this is called r. It's just r cosine theta, r sine theta. And just go into the videos to look up more of why and how that comes up. So now that's out of the way. And vector addition too. Find resultant is just a vector addition. So that's there too. Difference between a scalar and a vector. That's on my first video, which I will refer to. But just a scalar is just something that only has magnitude, and a vector has magnitude and direction. Know which physicals are quantities are which. So let's see right over here. So time is going to be a scalar because we only care about the absolute time. We don't really care about the past time. Distance, like we talked earlier on one of these examples, is going to be a scalar. Velocity is going to be a vector. Speed is going to be a scalar. All right, so just kind of have to memorize that. And acceleration, of course, is going to be a vector as well, which I covered this on one of my previous videos. So just I'll refer you to the link and check them out if you're confused with what they mean. If not, let's move on. Projectile motion. That is, again, addressed in another one of the videos, which I'll also be referring. But for example, like many times, the most complicated case is if you shoot something here at an angle, and then they ask you to find where it lands, so like the change in x, and then how much time it's on the air, what's the highest point, and all that stuff, which I cover completely on one of my previous videos, which I'll also be referring you guys to. So I'm just, for right now, what I figured I would just kind of touch on the topics and just let you know what each thing means, and then I'll refer you to a video so you can get personalized and individualized help. Cross current is something that I did not address in one of my videos, but I will be making a video soon about it. But it's just the same thing as projectile motion. You can think about it. Because, for example, if a swimmer is swimming not against, but perpendicular to the current, so that means that the water would be going this way. Right, and then the swimmer is going this way. Swimmer is going that way, and then, like, let's suppose he ends up over here, but he should have originated over here. Like, what is the distance or that he traveled down? So a change in y. And in this case, again, you have the x vector, right? This is your x component, and then you just need to know how much. So this will be the velocity in x, and this you need to know how much was the change in x. So then from v equals change on x over change on t, you would find t, change on t, and then you know how much he went down, right? And then in order to find how displacement is just velocity, which you would be given by the river, velocity times time, right? And notice that these times are the same. This time is this time, which you're just going to plug back into here. All right, so that's cross currents and time cross river. All right, now Chapter 4, relationship between mass and weight, forces, and velocity and acceleration. All right, so relationship between mass and weight. Mass never changes because it's just the composition of it. So mass never changes. This just means changes. However, the weight does. Weight does change. And the reason why is because weight is a force. And force, like I addressed on one of my previous videos, is force equals ma. So mass times acceleration, and the acceleration may change depending on the planet you're in. But in gravity, as the force of gravity is equals to mg, which is the weight that we feel in things. So I'll refer you to the force videos so you can take a look at that. I go over a lot of them. I go over a lot of force of friction and different types of force problems that will be really helpful for you in this case. All right, let's move on to the next color, and I'm going to switch colors. Next topic on how to find acceleration and velocity. So let me just cover that really quickly. So F equals ma, right? Remember, this little hat just means a vector. So if I know the force pushing on it and I know the mass, I can just divide by it, right? So there's mass equals acceleration. And remember from our kinematics, acceleration is what? Is velocity over time, right? So then you can just use this in order to find your velocity if you know the time. And also you can find, for example, the change in position, right? Using v squared equals to v naught squared plus 2a change in x, right? If you know the final and initial velocity, the acceleration, you can find the position. You just have to rearrange. So That's how the force connects to acceleration, which connects to velocity. All right, let's move on to the next one. Know and apply Newton's law. Find the net force and its significance. I covered this completely on one of our previous videos, so check that out for sure. I have 3 videos on forces, so I hope that's helpful for you. Inclined plane with and without friction. I was not able to address that one, so I apologize for that one. Freebody diagrams, let's go over that really quickly, which I went over in one of my videos. But for example, a box, right, and a surface right here. What are the forces acting on it? Well, force of gravity is going down, right? And the way I do this, it's always the forces are acting on the center of mass of the body. Normal force is going to go up. For example, if I'm pushing it this way, my force of person, let's say, is going to be force of person. And if there's friction, of course, because friction goes against the movement, the force of friction. So those are the forces acting over the body. That's what a free body diagram is. All right. So friction definitions and formulas, slide and problems. I go over this in one of my videos, which I will be referring you to as well, but just know that the official formula for friction is F friction equals to mu times the normal force. And mu can be 2 things. It can be mu sub k and mu sub s, which this just means static, and this means kinetic. All right. So I'll link the video so you can go over this if you need help with that. If you're not, then feel free to skip and go to whatever you need help with on the videos. All right, chapter 5. For chapter 5, it's circular motion and convert period to velocity. That I do not cover, but I will cover this on this video at the end. So centripetal force, formula, significance, velocity, and tension. I covered this in one of my videos, so I'll link you to that. But just know that the formulas for centripetal force, like this sheet lists that for sure, it's right here. F equals mv squared over r. So that's for circular motion, because it derives from ma. And a in the centripetal motion is v squared over r. All right. So again, I covered this in one of the videos. If you need more help, please click that link. And then here for the circular motion, find VA and convert it to period and time. It's just one formula, which is right here. So it's just T means period. Period is equals to 2 pi r, which is the circumference, divided by the velocity, so how fast you're going around the circle. Gives you the period. So then you just have to manipulate velocity, change it for t, and so on. All right, so circular motion is out of the way. And again, if you guys, I would really appreciate your feedback on this, because it's the first time I'm doing a study guide. So it's a lot to cover, and I'm trying to just get it done. And if you kind of explain and touch only on like what each thing means, and if you guys need help specifically with one topic, there's plenty of videos on my website and in the free YouTube channel and website, which is free as well. So yeah, check that out and let me know how I did. So elevator problem, tension, acceleration, velocity, and apparent weight. I believe I covered this in one of my videos. If not, please correct me on that, and I'll make one as soon as possible. Gravity, force, velocity of the satellite, and constants. All right, so for that one, all that we need and that we really care about is that the force of gravity, is actually or any type of acceleration in general in reality, G, M, big M, little m, so mass 1, mass 2, over r squared. In this case, it would just be G, which is a constant, which I covered this in one of my videos as well, over the mass r squared. This is the acceleration on any planet or the pull that you feel the forces just between two masses. So for example, the force of the Earth exerted on a satellite, right? It's given by this. So that's how you find the force. Okay. Velocity of the satellite. I address how to find the velocity of a satellite in one of my videos, so I'm going to skip that here. Constants. G is the only constant that will exist. And of course, on the radius of the Earth, so right on the surface of the Earth, we know that A is equals G, right? So in this case, on the surface of the Earth, so 1r, A equals G, which means this would equal this, right? So that way we can find the mass of the Earth if we need it, if we know the radius, and so on. So that's done. Kepler's law, I did not cover that on the video. However, the formula is just right here. T squared is proportional to r cube. So I highly doubt that your professor will cover a lot on Kepler's law, at least for Biola University. I don't know about your professor specifically, so let me know if they did, or if you want me to cover that in a little bit more extent. But so far, we were able to cover all of this, with except of the inclined plane and the Kepler's law extensively. But I hope this was helpful, and I hope the videos that I made can help you out if you have any questions with all of these things. So thank you for watching. I apologize for being however long this is going to take, but good luck with your exam, Biola. So please comment, let me know what I did wrong, what can I improve, what you guys would like to see on the website. So yeah, just good luck with your exam and good luck with studying, and I hope you guys learn physics and you get to enjoy it a little bit to see how the world around you works. So good luck with studying, and I'll see you next time.